4920. For maintaining level flight at constant thrust, which instrument would be the least appropriate for determining the need for a pitch change? A. Altimeter. B. VSI. C. Attitude indicator. The correct answer is C. The attitude indicator primarily provides information about the aircraft's pitch and bank attitude with respect to the horizon. It does not directly provide information about the need for a pitch change in order to maintain level flight at constant thrust. The attitude indicator's main purpose is to help the pilot maintain the desired pitch and bank attitude during various flight maneuvers. When maintaining level flight at constant thrust, the primary instrument to determine the need for a pitch change is the altimeter. The altimeter provides information about the aircraft's altitude, which remains constant during level flight. If the altimeter indicates a deviation from the desired altitude, it suggests that a pitch change is needed to return to the desired level flight. Similarly, the vertical speed indicator, VSI, can also provide useful information in determining the need for a pitch change. The VSI indicates the rate of climb or descent, allowing the pilot to adjust the pitch as necessary to maintain level flight. While the attitude indicator can indirectly assist in determining the need for a pitch change by providing a reference for maintaining the desired pitch attitude, it is not the most appropriate instrument for directly assessing the need for a pitch change in level flight. The altimeter and VSI are more directly relevant for this purpose. 4921. The displacement of a turn coordinator during a coordinated turn will A. Indicate the angle of bank. B. Remain constant for a given bank regardless of airspeed. C. Increase as angle of bank increases. The correct answer is C. The turn coordinator is an instrument that provides information about the coordination of a turn, specifically indicating if the turn is coordinated or uncoordinated. It consists of a needle and a ball, which move in response to the aircraft's rate of yaw and roll. During a coordinated turn, the needle of the turn coordinator remains centered, indicating that the rate of roll matches the rate of yaw. However, the ball will be displaced from the center position towards the outer edge of the turn coordinator. The displacement of the ball towards the outer edge of the turn coordinator increases as the angle of bank increases. The ball moves towards the lower wingtip in a coordinated turn, indicating the direction of the yaw resulting from the side slip caused by the bank angle. As the angle of bank increases, the forces acting on the aircraft change, and a greater displacement of the ball is required to counteract these forces and maintain coordination. Therefore, the displacement of the turn coordinator increases as the angle of bank increases. 4924. To enter a constant airspeed descent from level cruising flight and maintain cruising airspeed, the pilot should A. First adjust the pitch attitude to a descent using the attitude indicator as a reference, then adjust the power to maintain the cruising airspeed. B. First reduce power, then adjust the pitch using the attitude indicator as a reference to establish a specific rate on the VSI. C. Simultaneously reduce power and adjust the pitch using the attitude indicator as a reference to maintain the cruising airspeed. The correct answer is C. When transitioning from level cruising flight to a constant airspeed descent while maintaining the cruising airspeed, a combination of power and pitch adjustments is required. The goal is to maintain a consistent airspeed throughout the descent. Reducing power alone without adjusting the pitch would result in a decrease in airspeed, as the decreased power would not provide enough thrust to maintain the cruising airspeed. Similarly, adjusting the pitch alone without reducing power may result in a rapid increase in airspeed, as the increased descent angle would cause the aircraft to accelerate. To achieve a smooth and controlled descent while maintaining the cruising airspeed, both power and pitch adjustments are necessary. Simultaneously reducing power and adjusting the pitch allows the pilot to control the rate of descent while maintaining the desired airspeed. The attitude indicator serves as a reference for adjusting the pitch. By referencing the attitude indicator, the pilot can establish a pitch attitude that maintains the desired airspeed throughout the descent. The power reduction compensates for the increased descent angle, ensuring that the aircraft maintains the desired airspeed. 4925. To level off at an airspeed higher than the descent speed, the addition of power should be made, assuming a 500 fpm rate of descent at approximately a. 50 to 100 feet above the desired altitude. b. 100 to 150 feet above the desired altitude. c. 150 to 200 feet above the desired altitude. The correct answer is B. When transitioning from a descent to a level flight at an airspeed higher than the descent speed, it is crucial to add power at the right moment to prevent overshooting the desired altitude. Adding power helps to arrest the descent and transition to level flight smoothly. To determine when to add power, a general guideline is to do so when approximately 100 to 150 feet above the desired altitude. This lead allows the pilot to account for the aircraft's inertia and the delay between adding power and its effect on the rate of descent. By initiating the power addition 100 to 150 feet above the desired altitude, the pilot can anticipate the time required for the power to take effect and make a smooth transition to level flight without climbing above the intended altitude. 4926. To level off from a descent maintaining the descending airspeed, the pilot should lead the desired altitude by approximately a. 20 feet, b. 50 feet, c. 60 feet. The correct answer is B. When transitioning from a descent to level flight while maintaining the descending airspeed, it is important to lead the desired altitude to ensure a smooth level off without overshooting the target altitude. The lead refers to the vertical distance the aircraft should descend below the desired altitude before initiating the level off. By leading the altitude, the pilot compensates for the aircraft's inertia and the delay in response to control inputs. The appropriate lead distance can vary depending on factors such as aircraft characteristics, descent rate, and personal preference. However, a commonly used guideline is to lead by approximately 50 feet. By initiating the level off approximately 50 feet before reaching the desired altitude, the pilot allows for a smooth transition from descent to level flight without climbing above the intended altitude. This lead compensates for the aircraft's vertical momentum and ensures that the desired altitude is reached without overshooting.